When we are given a problem and it's not said that we have to use one particular method, whether node voltage method or mesh current method, so then we will have to use the method which is better, which will result in less equations, will be quicker to solve, easier to solve. So this is one that kind of a problem, and we will decide whether mesh current analysis is better or node voltage analysis. So what we have to do here, we have to find the voltage power dissipated by this current source. So this is our goal. So the current value we know, since it's a current source. So what we need is the voltage drop or rise across it, the voltage associated with it. So if we use let's say mesh current method, there are two meshes, so we will need two mesh. There will be two mesh currents, basically I1 and I2, and there will be a relation between the mesh currents. So I2 minus I1 will be 2, so I2 will be 2 plus I1. And then when we will write the mesh equation, since we do not know what is the voltage drop across the current source, we will take this outside loop, this big one, and we will write the equation. So basically what we will have to write, if I write the equation from here, we go in the clockwise direction, so 20 volts is a rise, let's write it as a negative, then 15 I1, this drop, then we will have this drop which will be plus 10 I2, and this 25 volts, this one will be drop as well since we are going in that direction, so like that 25, that is 0. So we will be able to solve this one because we have a relationship between I1 and I2, this one, so we can substitute I2 by I1, and if I do it, I will not do it here, so we will get something like I1 is equal to minus 1, and then we will get I2 accordingly, and so I2 will be I1 minus 1, I1 is minus 1, so I2 will be plus 1, like that, 1 ampere, minus 1 ampere, plus 1 ampere. So we know the current, so then we can actually find the voltage. We need basically this voltage, the voltage here, and since this is, if this we call reference voltage, we have a rise, 20 volts rise here, and then we will have a drop here according to the value of I1. So since we know I1, 15 minus I1, so the voltage, if we call this voltage Vm will be 20 minus 15 times I1, but I1 is a negative, so it will become 20 minus 15 minus I1, so that will be plus 15, so Vm, this voltage will be 35. So we know the voltage and the power will be 35 times 2. So it's still bit long. So if we see the other way, if we do node voltage method, so we have I have drawn the circuit again. I am doing now node voltage method. So this is my reference voltage and this is the voltage, let's call it Vm. So there is basically only one unknown, just one equation. So I just write KCL at this node. So that will be this outgoing current, and this current which is incoming. So we will have three currents. So the first outgoing current to the left will be Vm minus the voltage here will be 20, and over that will be 15, the resistance. Then I will have the other outgoing current to the right, that will be Vm minus 25 over the resistance is 10 ohms. So yep, that's 10 ohms. And then we have the incoming current, I'm writing on the other side, so that's 2. So now let's do it. Let's multiply both sides by 30. So we will have 2 Vm minus 40 plus, so I'm just trying to get rid of the denominator, just the fraction. So this is 3 Vm minus 75, and this will be 60. So now I have 5 Vm here, and then 60 plus 40 plus 75, which is 175. So Vm now becomes 175 over 5, which is 35 volts. So I arrived to that very quickly. So the power dissipated by the 2 ampere current source will be, it's the same equation, Vm times the current, which is 2, so that will be 70 watt. Same result, of course, but this one was quicker. I arrived to the result very quickly, at least quicker than the previous one, because I actually had to write 2 equations when I used mesh current method. But in this case there is only one node I am interested in, and I know when I look at it, I know that there is just one equation, because I have just one unknown and one equation, and that's how I get the voltage, and once I get the voltage I have the power. So actually we have to look at the particular problem, and then we have to see which method is better. Sometimes it's not very obvious. It's probably was more obvious in this one, but we will try to do some more and see where it's not very obvious probably.